The ongoing pandemic remains a high volume of research on the early detection of corona cases in dense population. The outline of today's presentation could be the introduction and the problem statement we have taken to solve in our project, and followed by the solution and the related work for the problem we have taken. Fifth could be the data and data source of our project. Sixth could be the tools and software languages we have planned to use in our project. Seventh could be the prototype, maybe a sample screen of what we're going to implement in our web application. Eighth could be the conclusion of the presentation. I think we don't need a formal introduction on COVID-19, but still, we gotta go. Coronavirus disease, alias COVID-19, is an influenza disease caused by a newly discovered virus called corona. COVID, as a pneumonia, damages the lungs and fills them with fluid, which makes them inflammable to a normal birth. As the pandemic continues to take millions of people's lives, yearly diagnosis of the disease is essential now. Radiographic images such as CT scan, CSR, play an important role in early detection and an observation of disease evaluation. But still, there is a high risk of false positive interpretation of COVID-19 in the images. For this, we need a system which predicts the COVID-19 in the radiographic images, also explains the COVID-19 marks in the radiographic images. That means you should able to explain why it predicted the particular image as a COVID-19. The testing is very crucial to the ongoing pandemic. It helps us to provide prompt treatment to the patients and also isolate the individuals who got contact with them to slow down the spread of the virus. But it's very time consuming to test the mass population with minimum resource and testing kits. A recent study shows that testing with CT scans and chest SRA provided a detected more cases in a very minimal time. For this, we need a system that could analyze patient CT scan and or chest SR images and predicts the presence of COVID-19 in the image. But wait, the new system will be trustworthy? Will people will accept the outcome result from a new system? No. For every new system, it's a very challenging to get people's belief and trust. For this, explanation is a key to help users to understand how and why a system works in the way it works.
Recognizing the decision class, that is COVID-19 positive or COVID-19 negative, is considered as an object detection task. This is achieved by taking the dataset and imposing the convolutional neural network architecture over the dataset and train the model, as shown in the figure. Every input image undergoes a set of convolutional layers, where a set of image filters are applied on different channels of input image to produce a set of activation maps. Every convolutional layer is followed by a pooling layer to reduce the dimension of image without losing vital information of the image. Once a set of convolutional and pooling layers are applied to the image, then the resultant activation maps are flattened and connected to the fully connected layer of the neural network to train and classify the image. The final output of the convolutional neural network architecture are the image classes and the respective accuracy of classifying an image to respective class. The class corresponding to the top accuracy is preferred for the decision. The deep learning models, especially the convolutional neural network models, needs a high computational cost to train the models. The concept of transfer learning helps reduce this effect by enabling the users to customize the pre-built models, which helps in reducing the training time and faster convergence. The pre-built models like VGG16, as shown in the figure, are a good starting point to initialize the network parameters rather than explicitly training a model with random parameter initializers. The class activation maps obtained from the final convolution layers in the CNN architectures are the main contributors of the decision classification in the network. An activation score is obtained by gradient flow backpropagated from every perturbation in the activation maps of this layer during the training. Interpreting the model classification is done by observing how good every activation map contributes to the final classification of the model. Hence, the input image regions corresponding to the ranked activation maps helps in interpreting the region of interest for final classification made as shown in the below figure.
So now we are going to talk about the data. So to accomplish this particular project, we have taken data from two sources. So one of the source name is COVID-19 CT, and another one name is COVID-19 chest X-ray database. Both of these data are published in Kaggle as well as in GitHub. So for COVID-19 CT, the authors of this uh, data set have taken the data from following websites like Medpix, Luna, Radiopedia, and PubMed. These all are nothing but specifically focused for medical related research, and where you can get specific like images such as radiographical images such as chest x-rays, CT scans, and other medical related uh, information. So and the other one is called COVID-19 chest X-ray database, where the authors have extracted the images of chest X-rays which has COVID-19, or which has which X-rays, patients X-rays which contain pneumonias, and even normal people, so as to distinguish between each of them. So yes, sure. So moving forward, so we will talk about COVID-19 CT data format and the size of them. So here, as we mentioned in the slide, like COVID-19 CT data set size is around 93 MB. It contains both positive and negative CT scan images of COVID-19 positive and negative patients. There is two folders in COVID-19 CT database. One is positive COVID-19, and another one is named as negative COVID-19. So in positive COVID-19, we have around 349 images of CT scans, and as opposed as well, and on negative COVID-19 CT, we have around 397 images. So, and the uniqueness of this COVID-19 CT, why we choose this data, because the authors took the data from 216 COVID-19 patients for accessing for analyzing the CT scan. So for compared to other data sets, those were only limited with 20 patients or 200 patients or 100 patients only. So because of their diversity and variety, we choose this data set. So the another data set, we as mentioned before, like the COVID-19 chest X-ray database. So this size of the data set, the size of this data set is around 1.2 GB. It consists mainly of X-ray images of viral pneumonia or positive COVID-19 patients, and even normal patients. Uh, so we had the and all of them are in .jpg format, and so it contains around 219 X-rays of positive COVID-19, and 1341 images of normal people X-ray images, and also 1345 images of viral pneumonia. And this data was extracted maximum from the
articles that have been mentioned before. So yeah, so
We have planned to use the below tools and languages to implement our project. To data storage and retrieval, we are planning to use PostgreSQL and Google Drive. To explore data and train the model, we are going to use Google Colab, Visual Studio as an IDE to build our application, and of course, Python and Django framework to build our web application. To implement our web application to the cloud, we are using Hierarchy tool. The following images gives an overview of our website, how it gonna be look and feels like. This is our homepage, and it gives the option for the users to upload their CT scan or chest SR images, and this could be our result screen, which classifies the input and also gives the explanation for the classification and also highlights the presence of COVID-19 in the image.
so as mentioned before, detecting COVID-19 in a patient in a very timely manner is very crucial. Uh, the recent technologies like the test being conducted using test kits such as RT-PCR, which are not that much reliable and are expensive and are time consuming. So we have come up with a solution of using chest X-ray and CT scan images to classify if the patient have COVID-19 or not. And we are also taking into an account of uh, normal viral pneumonia and COVID-19, and we are able to achieve this using CNN algorithm to classify the patient has COVID-19 or not, which is convolutional neural network. And also we are providing interpretability through which a doctor or a radiologist can see if the what AI model has outputted is explainable in a very proper way with the gradient, and that is being achieved using an algorithm called propnet. And this algorithm was published in neuro IPS conference in 2019, so we are going to achieve that here, implement that over here. And also we are going to develop a fully functional website to deploy our model. Yeah, thank you.